Hello students, welcome to the course Verilog HDL. In the previous video, we introduced you what is meant by behavioral modeling, and we have taken the first topic, that is structured procedures, initial and always statements. Okay. So today in this video, we take the second topic, that is procedural assignments. Okay. So we'll go with this in detail. Procedural assignments update values of register, integer, real, or time variables. So these are nothing but the data types, right? Register, integer, real. So to update that, the values, so assignments will be used. The value placed on a variable will remain unchanged until another procedural assignment updates the variable with a different value. For example, A is a variable you have declared, so you have assigned some value 10. So this value of 10 assigned to A will not change unless there is a next statement comes and place that value A equal to 5, something like that. Okay, so that is procedural assignment. So these are unlike continuous assignments discussed in data flow modeling. Okay, where one assignment statement can cause the value of the right hand side expression to be continuously placed onto the left hand side net. Okay, so that was done in data flow modeling using assign statement. Continuously it was placing the values on that, but here it will little differently it will work. Okay, the syntax for the simplest form of procedural assignment is shown below. So this is the syntax. Okay, so while writing only you will understand this. So assignment equal to symbol will come, variable value, so what you are going to assign the value, equal to if any delay is there, that part will write it here, delay or event control. And then the expression is nothing but combination of operands and operators, so that will come over here. Okay, so you'll see the example, so this will be clarified to you. So in procedural assignment, the left hand side of a procedural assignment, that is L value, will say can be any one of the following. It may be a register, integer, real, or time register variable, or a memory element, or it can be a bit select of these variables, or it can be a part select of these vectors variable. Okay, or it can be a concatenation of any of the above things. Okay, so that is the value it will take by the left hand side statement. The right hand side can be an expression. It is always an expression part, we have learned in data flow in detail. So it should be an expression that evaluates to a value. Okay, there are two types of procedural assignment statements are there. Okay, so this is important, blocking and non-blocking. Okay, so blocking is indicated by a single equal to operator. Okay, so this equal to means it is a blocking assignment statement. So if you write a less than or equal to, so this also will write in Verilog. This is nothing but non-blocking assignment. Okay, so what is the difference among this and what is the use of this? So that is what the interest of today's topic. Okay, so we'll proceed this with in detail. Okay, so first we'll consider the blocking assignments. Blocking assignment statements are executed in the order they are specified in a sequential block. Okay, so sequential and parallel block topic we have, we'll learn it in next. Okay, so sequential man, you have a begin and end. Okay, so where it will begin, where it will end, and what all the statements you have written inside that, it will be executed in the step by step manner. After this only, after this only, that is the order. A blocking assignment will not block execution of statements that follow in a parallel block. Okay, so this sequential block, parallel block concept we have in, we'll take it in the end. Okay, so if you have written in sequential block, then it will execute in the order. The same blocking assignments, the same blocking assignment, if they are written inside a parallel block, then they will not work like this. It is okay, it will not block. So the equal to operator is used to specify blocking assignments. This is what I told you. Okay, so this is the operator used to specify blocking assignments. So this is the example, so it will clarify your doubts. Okay, or the concept in better manner. So we have declared variables xyz as registers, and then we have taken vectors also, register a, register b, and integer count, and we have written a set of statements here inside the initial, begin and end. So when we have used begin and end, it is a sequential block. So in the sequential block I have written multiple statements here. Okay, and they will be executed in the order. For example, x equal to 0 is in the beginning, then you have y equal to 1, and then you have z equal to 1. Okay, all are written in single line, but it is a different execution time. Okay, but here x equal to 0 is executed first. Okay, then y is equal to 1 executed. Okay, and then z equal to 1. So y equal to 1 is not executed unless this is executed. Okay, so that is what called as in the order. Okay, although they are all having same time, 0 simulation time only, all are 0 simulation time. Okay, until this register B, all are having 0 simulation time only, they are executing. But there also, because of this blocking assignment statement, they will execute in the order, first x, y, z, then count, then register A, then register B. Whereas when it comes to register A of 2, it is having a delay of 15. It will add with this 0 plus 15. So 15 time units, the 1 bit value 1 is equal to assigned to A of 2. Okay. And after that only this statement. Okay. 15 plus 10, 25, 10 minutes. This is executed. Okay. Although this statement count equal to count plus does not have any delay, but it will execute at the time units 25 only, because this is 25 now. After that, whatever comes, that is at the, okay. So this is the idea of a blocking assignments. Whereas in non-blocking, it is reverse. Okay, that also will look. So just we'll try to explain this part, how the statements will execute. Whatever I have explained, that I am summarizing. In example, the statement y equal to 1 is executed only after x equal to 0 is executed. That's what I mentioned. The behavior in a particular block is sequential in a begin and block if blocking statements are used, because the statements can execute only in sequence. Begin and end we have used, that is called as sequential block. Okay, more detail we'll learn it in next topic. And they will execute only in sequence. And the last statement you had there, right, count equal to count plus, it is executed last. The simulation times at which the statements are executed as follows. Okay, all statements from x equal to 0 to register B equal to register A. So all this will execute at time 0 only, because there is no delay mentioned there, but they will execute in the order. Then statement register A of 2 equal to will execute at 15. Then next statement will execute at 25. Okay, 10 delay is there, 50 plus 15 plus 10, 25. Then statement, last statement count equal to count plus 1 will not execute at 0 time unit. It will execute at this time 25 only. 25 plus 0, like that it will calculate. Okay. Since there is a delay of 15 and 10 in the preceding statement, count equal to count plus when we executed at time 25 units only. Okay. So from this example, hope some of the things clarified to you what is meant by blocking assignments. Okay. Note that for procedural assignments to registers, if the right hand side has more bits than the register variable, the right hand side is truncated to match the width of the register variable. For example, left side we have taken 4 bit. If right side you have the bit of 5 bit width, when you equate that, assigned it, so the right hand side value may be truncated. Okay, so some of the additional things in blocking assignments. Okay, then the least significant bits are selected and the most significant bits are discarded. Okay, so least significant bits is selected and the this is the step it will follow. If the right hand side has fewer bits, zeros are filled in the most significant bits of the register variable. If it is less than that, then it will fill with zeros to match the number of bits. Okay, so this is the idea of a blocking assignment. So now we'll take the non-blocking assignment and then we'll compare both. Non-blocking assignments allow scheduling of assignments without blocking execution of the statements that follow in a sequential block. So it does not follow as the same example. So whatever it may be, okay. So it will not wait for the count equal to count plus 1 to wait for the previous block. Parallelly, they will be executing and they will end at the different time. Okay. So that is non-blocking. So here less than or equal to operator is used to specify the non-blocking assignment. Okay. So this is the noting factor here. Note that this operator has the same symbol as a relational operator, less than equal. Okay, so don't confuse this. So here when you have written in the assignment, it is a non-blocking assignment. Otherwise, it will be there in the expression. The operator is interpreted as a relational operator in an expression. Okay, and as an assignment operator in the context of a non-blocking assignment. Context, it will different. Okay, so here non-blocking assignment, it is used same operator. In the case of expression, it will do the less than or equal to and it will give the logical answer. Okay, to illustrate the behavior of non-blocking statement and its difference from blocking statement, let us consider example where we convert some blocking assignments to non-blocking assignments and observe the behavior. Okay, so this is the same example what we have considered earlier. I am taking now, but execution wise it will change, that we are going to observe. The same statement I have, register xyz. Okay, everything x equal to 0, y equal to 1, z equal to 1. So everything. Okay, so here delay is specified here. Okay, so when non-blocking assignments are there here, all the right hand side part, okay, all the right hand side whatever you have. Okay, so register a here. Okay, this is one bit assignment, whereas here some operations are there, concatenation xyz, here count plus 1. So this right side we call it as the read operation. Okay, so just it will read the value 1 0 or whatever operation, it will do that and it will 0. And right side it is called as the write operation. So this less than or equal to whatever we are assigning value here, it is called as the write operation. Okay, so this is read and that is write, and this write operation will happen with respect to the delay mentioned here. Okay, so here in this case and all it is 0. So now count equal to count plus will not wait for this register b to do. Okay, since it is at the 0 time only, so all are at the 0, all these are 0, and whereas this has a 15 delay, so it will execute at 15 time minutes. Whereas this it will not wait for this statement to execute, this it will execute at 10 time minutes and it will finish its process. All are in parallelly they are executing, just because of this less than or equal to. Okay, so whereas here blocking statements are used here, so that's why these will execute in order. So these will execute in order till here, whereas this it will not execute. Okay, so this it will execute at the 0 time, non-blocking, right? So this it will execute at 10 15. Okay, hope it is clear somewhat. Okay, so just we'll summarize that. Okay, with respect to simulation time, in this example the statements x equal to 0 through register b are executed sequentially at a time 0. They are sequentially they will do because of the blocking assignment operator equal. Whereas then there are three other non-blocking assignments are processed at the same simulation time. Register a of 2 equal to 0 is scheduled to execute after 15 time minutes. Okay, 0 plus 15 it will count. Then register b equal to xyz is scheduled to execute at 10 time minutes. It will not take now 15 plus 10, 0 plus 10 only. Okay, that is the difference. Then count equal to count plus 1 is scheduled to be executed without any delay. That is at time 0 only it will execute because of the less than or equal to. So this is a change here. Okay, in the example above we mixed blocking and non-blocking assignments to illustrate their behavior. We have just mixed them to understand or differentiate their behavior. However, it is recommended that blocking and non-blocking assignments not to be mixed in the same always block. So this is the recommended. Okay, you should not use, just for illustration I have used here, but it is highly recommended you should not block write the blocking and non-blocking in a single always block. Always we have learned yesterday. Okay, repeatedly it will do, no? So there if we do, chances of error will be there. Okay, that's why it is not recommended. We are learning the language constructs. Okay, so in each point. So thus the simulator schedules a non-blocking assignment statement to execute and continues to the next statement in the block without waiting for the non-blocking statement to complete execution. Typically, non-blocking assignment statements are executed last in the time step in which they are scheduled. That is, after all the blocking assignments in that time step are executed. Okay, in case if you write that, so this is how it is going to interpret that. Okay. Then we'll see the application of non-blocking assignments. Okay, so when we have these two types, so one is having advantage over another, so not both are, first one is bad next one is good, no, they have different context, their own role. Okay, that we try to understand. So they are used as a method to model several concurrent data transfers. Okay, just one word to say the application, it is concurrent data transfer or parallel data transfer, simultaneous data transfer. Okay, so that takes place after a common event. Consider the following example where three concurrent data transfer takes place at the positive edge of clock here. So you have written always at pause edge. This is a keyword for indicating positive edge of the clock, pause edge. Negative edge also neg edge. Here also it is mentioned. Okay. So clock is the variable. Begin register 1, number 1 in 1. Okay. So register 2 at negative edge clock into XOR in 3, register 3, number 1, register 1. Okay, so the old value of register 1 it will, okay, so how it is going to execute in non-blocking? So this it will consider it as read operation first, in 1, in 2 or in 3, and register 1 it will consider as read operation, and based on the time delay here. Okay, so register 1 will value take the value of in 1 at 1 time unit delay, and register 2 it will take the value of into XOR in 3 at the next negative edge. So pause edge this will happen, negative edge this will happen, then again at a delay of 1 time unit, so register 1 is assigned to register 3. Okay, so this example only, 3 concurrent data transfers we will try to elaborate now. Okay, at each positive edge of clock the following sequence takes place for the non-blocking assignments. Okay, so this is the step try to explain here. First thing, the read operation is performed on each right hand side variable, the read operation. Okay, in 1, into in 3, and register 1 at the positive edge of clock. The right hand side expressions are evaluated and the results are stored internally in the simulator. Some internal variable it will be stored, not assigned. Okay, so right hand side all the expressions evaluated and their values are stored some internally. Okay, temporary variable. Then when write operations to the left hand side variables are scheduled based on the delay to be executed at the time specified by the intra assignment delay in each assignment, that is schedule write to register 1 after 1 time unit, register 2 at the next negative edge of the clock, and to register 3 after 1 time unit. Okay, so accordingly, so this will be executed. Okay, so then third step, so the write operations are executed at the scheduled time steps. Okay, the order in which the write operations are executed is not important because the internally stored right hand side expression values are used to assign to the left hand side values. Okay, so based on their internal computation time, so it will be assigned. Okay, for example, note that register 3 is the last one, assign the old value of register 1. Okay, so first statement you have register 1 equal to in 1 something is there. Okay, but when it is doing read operation, so this register 3 has the register 1 has the old value. Okay, it was read. Okay, and when it is given assign, so it will copy the old value of this to register 3. Okay, so just to show you here, register 1 you have the in 1, and register 3 I am doing register 1. If this is a sequential blocking statement, so after this only this will execute. Okay, after this only this will execute, then this register value whatever is there in 1 value it will be stored in register 3. Now since it is a non-blocking assignment, so first case read operation is happened first, right? In 1, into in register 1, register 1 whatever previous value was there it will be stored there, and when you give write operation, so it is just register 3 will take the old value, not the new value. In the next positive edge of the clock, so it may take the new value in 1. Okay, so like that. Okay, that is the idea. Thus, the final values of register 1, 2, and 3 are not dependent on the order in which the assignments are processed. So that is the application of non-blocking assignment. Another important application is to eliminate race conditions. Okay, so what is this? So we have to understand by an example, eliminating the race condition. To understand the read and write operations further, consider example below, which is intended to swap the values of registers A and B at each positive edge of clock using two non-current always blocks. So what is the idea here is, for example, I have a equal to 10, okay, and B equal to 20. Okay, imagine. So I need to swap the values. Whatever values is in B, it should come to A, and whatever values is in A, it should come to B. Swapping. Okay, for that we'll use both the blocks, non-blocking as well as blocking. So what is the advantage, disadvantage? We will discuss. Okay. First illustration 1 here, two concurrent always blocks with blocking assignment we have used. Blocking statements we have used. Always at positive edge of clock A equal to B, always at positive edge of clock B equal to A. What will happen? All the always blocks will execute at time 0. So that's why A equal to B, B equal to LA. What will happen? A equal to B will execute first, sequential execution, right? Then B equal to A is execute. So B value is assigned to A, and this A value only back assigned to B. That means what? Swapping will not happen. Whatever value of B is there, 20, it will be there in both. B equal to A equal to 20, B equal to 20 will happen. So swapping will not happen here. And again, both are at 0 time units. So which one will execute first also we don't know. We could not predict here. It can have value 1010 or it can have value 2020. This may execute first A, and this value only will be there here. Don't know what will happen. Okay, so that's why it is called as race condition. Okay, so who is going to execute first is not known. So we'll take a second illustration where we'll do concurrent always blocks with non-blocking assignments we'll use. Same statement, we'll write less than or equal to B, B is less than or equal to A. So when you write like this, so this will do the read operation first. So B will have first read operation, it will take 20 and A will have the 10. And when positive edge clock comes, so just it will do the write operation. So A will be return 20 and B will be return 10. Okay, so just it is swapped. A got 20 value and B got 10 value. Okay, so swapping is done perfectly in non-blocking. So this is the application of the non-blocking assignments to eliminate race conditions. Okay, so this only the important I told you. So this only elaborated here. In example, in illustration 1, there is a race condition when blocking statements are used. Either A equal to B would be executed before B equal to A or vice versa, depending on the simulator implementation. It is unpredictable. Thus, values of registers A and B will not be swapped here. Instead, what we'll have, both register will get the same value, previous value of A or B. It may be 1010 or it may be 2020 based on the Verilog simulator implementation. So this is called as a race condition. Okay. However, non-blocking statements used in illustration 2 eliminate race condition. Okay. At the positive edge of clock, the values of all the right hand side variables are red, and right hand side expressions are evaluated and stored in temporary variables. So these values are stored in some temporary variables, and when it comes to the write operation, that means assignment, after a delay, the values stored in the temporary variables are assigned to the left hand side variables. Okay, separating the read and write operations ensure that the values of registers C and B are swapped correctly regardless of the order in which the write operations are performed. So you don't think that you could not do in blocking assignments the same operation. We can do, but we have to take a exclusive temporary variable to store the A value and B value, and then you can swap it. But in case of non-blocking, no need of taking temporary variable. It will internally do that part. Okay, so just read and write operation, it will do that part. Okay, so for you to clarify, we will show you example where we can use the blocking assignment using the same. Okay, temporary variable you consider. Okay, to emulate the behavior of non-blocking assignments by using temporary variables and blocking assignments. Okay, whatever non-blocking assignment has done, now we'll do using blocking assignment. To eliminate race conditions, we'll use temporary variables. Okay, so always at positive edge of clock begin, so we'll take two variables, temporary variable A, temporary B. So it will first store the values of A and B, then we'll make it right. Okay, A equal to temp B and B equal to temp A. So with this, what will happen, so this statement will be executed first. So A is having value 10, so it will be stored in 10, and B will be having value 20, so it will be stored in 20. Okay, and in the next statement, what will happen, temp B will have value 20 now, that will assign to A, that is swapped, properly swapped here to A. A was having 10, now temp A is having 10 value, so now it is assigned to B, so now B will get the 10. So this is successfully doing same as in non-blocking assignments. Okay, only thing is these two you have to do, temporary variables you have to declare, you can do. Okay, so that is the difference between blocking and non-blocking assignments and how it will eliminate the race conditions. Okay, so just to summarize, for digital design, use of non-blocking assignments in place of blocking assignments is highly recommended in places where concurrent data transfers takes place after a common event. Okay, whenever you have a concurrent data transfer, it is better to go for non-blocking assignments. Okay, clear? In such cases, blocking assignments can potentially cause race conditions because the final result depends on the order in which the assignments are evaluated. So why we could not use blocking, because it will bring race condition there. Okay, and non-blocking assignments can be used effectively to model concurrent data transfers because the final result is not dependent on the order in which the assignments are evaluated. So it is splitted into read and write operations. Because of that, problem is solved. Typical applications of non-blocking assignments include pipeline modeling. Okay, so in microprocessor architecture and all, you have learned about pipeline. Okay, so to model that, this non-blocking assignments will be used, and modeling of several mutually exclusive data transfers. Okay, mutual exclusive data transfer. So non-blocking assignments are used. And on the downside, non-blocking assignments can potentially cause a degradation in the simulator performance. Okay, so this may cause the degradation. This is the drawback of non-blocking assignments, and it can increase the memory usage. Okay, because internally it will store the values, no temporary variable. So that's why, because of that, memory use increase it will happen, and degradation in the performance. That means delay will happen. Okay, so this is about the non-blocking and non-blocking assignments called as procedural assignments. Okay, so with this we'll end the session here. Okay, so in the next video we'll come with a new topic on behavioral modeling. Okay, thank you.